You're being recorded. Right, everyone, it's being recorded. Please do not swear. Right, okay, at me. Right, probability 2. So here we go. So the first one is tree diagrams. Okay, we know how to do a tree diagram why did I do that? We know how to do a tree diagram from junior cert, except now we're going to put the probabilities onto the branches. Right, okay, so I will show that with a tree diagram. The outcomes or 2 or more events can be shown in a particular type of diagram called a tree diagram. Okay, 2 or more events. Please note you can only use the two-way table for 2 events. Right? Tree diagrams, 2 or more. So, you know, you can be picking red, blue and green balls. Right? Okay, out of a bag. Right? Whatever. Right? Each branch represents a possible outcome of one event. The probability of each outcome is written on the branches, okay? So that's what's different this year from our tree diagrams up to junior cert. And I think maybe towards the end, maybe there was 1 or 2 questions towards the end of junior cert where we actually did this, but we're going to do this now as a matter of, yeah. And the probabilities are not going to be the same. Okay, are you ready? No. Are we good? Okay, everyone? Right, okay, example 1. Bag A contains 2 blue counters. It's page 198, question 7 if you don't want to write it down. Okay, so it's page 198, question 7 if you don't want to write it down. Okay? Will I go? There are people writing this down? No, you're not writing it down, or no, don't go. Right. Don't go. You ready? Yeah? Okay. I'll put up the PowerPoint anyway. Okay. Shh. So bag A, we can get a blue or we can get a white. Okay? But we're going to put in the probabilities now. So out of bag A, there's 2 out of 5 are blue, right? And there's 3 out of 5 are white. Okay? So this, the difference in our tree diagram is we're writing in the probabilities on the branches. Okay? Then we're going to do bag B, right? Okay? So there's 2 choices out of bag B as well, blue and white. Okay? So that's bag A, this is bag B. We go with blue and white again, right? So blue and white. Okay? This time the blue is a 3 out of 7 chance. And the white is 4 out of 7. And the blue is 3 out of 7. And the white is 4 out of 7. Okay, so then answer the questions, right? What are the chances? Complete a tree diagram to show all possible outcomes, work out the probability the counters will both be white. So that means you want to get a white and first out of bag A, and then you want to get a white out of bag B, right? Okay, so it's really good because all your stuff is written out. So your white out of bag A, what's your chances of getting a white out of bag A? 3 over 5, and means you multiply. What's your chance of getting a white out of bag B? 4 out of 7, and what's that? 21 over 3 fours are 8, isn't 21. 3 fours are 12 out of 35. Okay, and I said that in camera. Okay, I could be fired for that. Right, 3 fours are 21. Right, what's the problem? Yeah.
So where are you getting 3 out of 5 and 4 out of 7?
3 out of 5, the first bag. There's 5 balls in there, and 3 of them are white. Okay. So your chance of getting a white ball is 3 out of 5.
Oh, so there's 4
yeah.
white balls.
And then in bag B, there's 4 white balls out of 7 balls, so 4 out of 7.
But then why in the tree diagram is it 3 out of 5 white?
Because there's 3 white out in the first bag. This is bag A. So you do bag A first, so you pick twice. So you pick out of bag A and then you pick out of bag B, right? So these are the probabilities for bag A, that's why A is written up here, and these are the probabilities for bag B because bag B is written here. Because what?
Why is there 2 things twice? Like for bag B, like why did you write that twice?
Because from bag A you could pick blue or white. Yeah. So after you pick blue, when you go to pick again, you can pick blue or white. But if you picked white out of bag A, when you pick again, you can pick blue or white. Okay, do you know what I mean?
Yeah.
So out of bag A, you pick a blue or a white,
yeah.
Right? So if you pick a blue, and when you pick again, you can pick a blue or a white again, can't you? And if you pick a white, you can pick a blue or a white after you pick the white.
Okay.
Okay? So the next question is, what's the probability they're both blue? So that means you want to get blue and blue. So bag A, blue, what are the chances of blue? Out of bag A? 2 over 5. N means you multiply. What are your chances of blue out of bag B? 3 over 7. There's 3 blue balls and there's 3 out of 7 blue balls. Right, and that's 3 twos are 6 over 35. Okay, is that alright? Then the next one is, what are your chances they're the same colour? Now, you have to rephrase this. Right, okay, so what are the chances they're the same colour? So how would they be the same colour? They could be they could be white and white, couldn't they? That's one option. Or, what's the other option? Blue and blue. They're the only ways they could be the same colour. Agreed? So they could be white and white or blue and blue. You've just worked out white and white. It's 12 over 35. Or means you add, and you've just worked out blue and blue. It's 6 over 35. So what are the chances that they're the same colour? 18 out of 35. Okay? And it's when you have a tree diagram to look at it, it's way easier because you're like, you don't have to be, am I in bag A, am I in bag B, where the hell am I? Right, okay, is that alright? Happy with that? Right, okay, so even if they didn't tell me to draw a tree diagram here, I'd draw one, okay? Because, you know, it really helps. Okay, example 2. I'll go back to example 2. And if we don't feel like writing it down, right now, a bag contains 2 black counters. Is that the same thing? No, we're black now. Oh yeah. Black and... I'll find it. Hang on. And the other ones. Sorry. Did I say the last one was question 7?
Yeah.
It wasn't.
It was question 3.
It was question 3.
Yeah.
Okay.
Question 7.
Yeah, sorry. The last one was question 3. This one is question 7 on page 198. So just change the last one to page 198, question 3. And this is page 198, question 7, if you don't want to write it down. Okay, ready? Are you writing? You're writing. Okay, so I'll draw my bag again. 2 black and 4 white. 2 black, 4 white. And then I'll draw my other bag, which has, oh no, same bag. Don't. Right, okay. Counter is taken from the bag and not replaced. A second counter is then taken, okay? So, not replaced, that's really important, right? So you take the ball out, you look at it, and throw it in the bin, right? Okay? So that's really important, that not replaced, because it changes everything, okay? So, are we good? Going, gone? Right, okay, so, is that funny? No, it's alright, is it? Hang on now, I just want to do one more. No, it's just what it's coming out of. Right, so a bag contains 2 blacks, so basically, when you pick, you can get black or white. And then we're going to pick again, right, a second counter. So again, if you picked a black first, then you could get a black second, or you could get a white second. If you pick a white first, you could get a black second, or you could get a white second. Agreed? Right, let's put in our probabilities. So we're picking first. Out of the first, your chance here, how many black? 2 out of 6. How many white? 4 out of 6. Okay, now here you picked a black ball, right? Okay, so you picked the black ball, you're not putting it back. The black ball is gone in the bin. So that means I'm down to 1 black ball. For the second, so for this, yeah, for the second pick, I'm down to 1 black ball. So what are my chances of getting the black ball now when you pick a second time? 1 out of 5. Your 1 black ball has disappeared, right? Okay, and there's only 5 balls left, right? What are your chances of getting white? Yeah, there's still 4 white balls, but we said we've only 5 balls now. Okay, right? Same here, except this time you have to assume. So you're back up to 2 black. So down here you have to assume the ball you pick is white. So I'm down to 3 white balls. Okay, so you assume the ball you pick and throw away is whatever this is. So what's your chance of getting black on a second ball? 2 out of 5. And what's your chance of getting white on a second pick? 3 out of 5, isn't it? Is that okay? Does everyone see where all that came from? Okay, and then answer the question. What's the probability that they're the same colour? Okay, so the same colour means they're black and black, or they are white and white. Okay, so when they say the same colour, you have to actually split it into the colours. So black first. What's the chance of black first? 2 over 6. And means you multiply. What's your chance of getting a black second? 1 over 5. Or means you add. What are your chances of getting a white first? 4 out of 6. And means you multiply. What are your chances of getting a white second? 3 out of 5. Okay, so that would be 2 over 30, add 12 over 30, which is 14 over 30, or 7 over 15. I'll just leave it as 14 over 30. Is that right? Is that okay? Both the same colour. Right? Different colours. Right. What are your chances of getting different colours? So you could get, put it in language for me. So different colours, what could we do? We could get a what? A black first, and then a white. Or we could get a white first, and then a black. So you have to take into account the order. Okay? So white first, black first, 2 over 6, and means you multiply. White second, 4 out of 5, or means you add. White first, 4 out of 6, and means you multiply. Black second, 2 out of 5. Is that okay? And that would be 8 out of 30, add 8 out of 30, isn't it? So that would be 16 out of 30, or 8 out of 15 if you like. Is that okay? 3 diagrams? Happy enough with them? Yeah, I don't have a third one. Do you want to try one and then we'll move on to expected value? Because I'd say they're handy enough. So we have a go at page 198, number 5. Right? Page 198, number 5. Okay? The 3 diagrams even drawn for you, you just have to fill in the probabilities on it. Right? And do this as quick as you can so I can go on to expected value. Are you okay?
For the one that you just did.
Yeah. Did I make a mistake?
Yeah, it was for like the B and the D.
B and the W, B and the W, 2/5, 2/6, and then the W is 4/6, and the B.
Why was it 4/5 and then 4/6 for the definition?
The W,
Yeah.
right, when we're going white first, this one,
Yeah.
white first,
Why did the number of balls change?
because you took a ball out and you threw it away. In the question it said the ball was not replaced, right, okay? A counter is taken from the bag and not replaced. So basically, in this case, you assume it was a black ball, so you take it out and throw it in the bin. So I'm gone down to one black ball out of, there's only 5 balls left in the bag now. Because I took a black ball out and threw it away. Okay, and down here you assume you took a white ball out and threw it away. So you're down to 5 balls, but you still have 2 black, but you're down to 3 white.
Oh yeah.
Is that okay?
Yeah.
Yeah. So that's really important when you're reading the question, when they're picking balls out of a bag or whatever, that they say it's replaced or not replaced, okay? It's really important. Number 5. Is that what I said? Come on girls, number 5 until I move on with stuff. Are you talking about number 5, Louise? Because if you're not, I'm going to go.
I am.
No, you're not.
I am.
You are not.
I am it.
Find the probability that both cubes land with the same colour. Are we good? No. You need help. Right. Ever need help?
Yeah.
Right, okay. So,
It's zoomed in.
zoomed in. Right, great. Thanks for telling me, because I would have zoomed away there and went out. Right, okay, so what have we got? Red, blue, green. So, red, blue, green. Right, and that's the first one. What are your chances of red on the first one? 2 out of 6? Blue? Also 2 out of 6, is it? The first one, cube A, 2 out of 6. 2 blues. First one, 2 out of 6. And green, 2 out of 6. Sorry, that looks like a 3, that's a 2. So there are 3 of them are 2 out of 6, okay? Then you go again with the second cube, so you can get red, blue, green, get red, blue, green, and you can get red, blue, green. Okay, right, let's see for the second one. Second one, QB. So we've 1 red, yeah, 3 blue, and 2 green. So 1 out of 6, 3 out of 6, and 2 out of 6, yeah? Is that alright? I know it's hard to see. So that's the same, 1 out of 6. There's 3 blue, isn't there? 3 out of 6, and there's 2 out of 6 green. And then the last one, it's still 1 out of 6 red, 3 out of 6, and 2 out of 6. Yeah? Okay? The tree diagram okay? Right, okay. So then we go, find the probability that both cubes land on with the same colour on top. So that means we need to go red and red, or I might do it down. No, I won't. I want to do it beside it. Red and red, or blue and blue, or green and green. Would you agree? Same colour? Are we okay with that? So red and red. So the first red is 2, 6. Right? Multiplied by the second red is 1/6. Right? 2, 6 by 1/6. Right? Add. Blue, first one blue is 2, 6. And means you multiply second one blue 3, 6. Right? Or means you add, and then we have a green. First one green is 2, 6, and means you multiply. Second one green is also 2, 6. Is that okay? Right, and into the calculator with that, that would be 3 over 36. No, it wouldn't be. It would be 2 over 36. 2 over 36. Add 3 2 6 over 36. Add 2 2s are 4 over 36, which is 12 over 36, which is 1/3. Happy with that?
Yeah.
Same colour? Right, okay. And the second question is different colours. Okay, so different colours. Have we to do the whole lot out? No, it's one take away the same, all the same. One is? One take away all the same. You know what are your chances of getting 2 the same colours? So if they're not the same, they're different. Would you agree? That's what I think. So I'm thinking 2/3.
No, the question is blue and green.
Oh, sorry, I'm reading the wrong question. Right, okay. Where am I? Find the probability the one of cubes lands blue and the other green. So we can go, it doesn't say order, so it's blue and green. Or it could be green and blue, couldn't it? It doesn't say the order. It doesn't say blue has to be first. It says blue and green, blue and green. One is blue, one is green. It doesn't say in the order. So blue is 2 over 6. Blue first, 2 6. Multiply green second, 2 6. Right? Or means you add green first, 2 6. Or and blue second, 3 6. Right? And that's 4 over 36. Add 10 over 36. 10 over 36, 5 over 18.
Yeah.
Is that right? Are we good with that? Okay. Do we need another one? That's it. No.
we're okay.
Yeah. Right. We might practice some more tomorrow. Actually, what we'll do tomorrow is the other book. When we come back to this book, we'll do more then. Right. It's 16:39. So I won't have time for expected value, but we still have 6 minutes. So let's do one more. I love this one. Let's do number 9, page 199, number 9. Come on, we're here for a good time, not a long time. Or is it the other way around in this case? No. Do you know what I did the other day? I dropped the picker-upper. Oh God! Yeah, so I had to use the hook thing to pick up the picker-upper thing, and it was like, so it was a disaster in here. I thought I was going to have to go for help. Yeah, I also dropped someone's question sheet, and I'm not going to squash it very much. Sorry. I'll tell you who I'll apologise to. Who am I apologising to? I come with somebody's question sheet. I apologise, Bo. So you finished, Louise, yeah?
Yeah.
You're not leaving this room until I see number 9.
It's
I am tired too, and I'm older.
not an example of what we're doing.
Oh no, you're doing it. There's no examples anymore. It's all about ye. So I'm going to just go or and NR, not really. So late and not late. So I go L and not late. And late and not late. There was one on a leader paper that was very like this. A little bit more complicated. So the probability it's going to rain tomorrow is a third. So not raining, what's the probability it's not raining? 2/3. Right? Chance of him going to be late is a quarter. So what's the chance of him not going to be late?
3/4.
3/4 up there. And they tell me if it is not raining if it is not raining he'll be late is 1/5. So what's the chance he won't be late if it's not raining? 4/5. Okay, so there's the tree diagram done. It makes life so much easier when it comes to answer the questions. Right, okay, find the probability that Simon will be late for school tomorrow. Right, so there's 2 ways he's going to be late.
This person. How does it become 1/5? Oh, it says it there.
It's yeah. So you want him to be late. So there's 2 ways he's going to be late. It's going to be raining, and then he's going to be late. Or how else is he going to be late? Or it's not raining, and he's going to be late. Don't worry, Louise, I'll do it now.
Sorry.
Right. So the rain is 1/3 and means you multiply, late is 1/4, right? Or means you add. Then the other way he's going to be late, if it's not raining, which is 2/3, right? And means you multiply, he's going to be late, which is 1/5. Right? Into the calculator, that's 1/12, add 2/15. I'll leave you at them on the calculator because 12 and 15. What is 12, 15, 60, I suppose. Was it? 13 over 60. Okay. I won't give you any homework, but have a look over these 3 diagrams again, right? Okay. And bring book 4 tomorrow because we have lots of questions to do in book 4. Lots of hard questions to do in book 4. Right, bye now.